Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and here we are going to utilize the concept of Leibniz integral rule. So here we are given this problem where a function f is given to be a continuous function, and this function f is defined by this equation, that is integral 0 to t cube, and here we have f of pi x minus 2 pi x raised to 4 dx is equal to pi times t raised to 4 for all values of t greater than 0, and we have to find the value of f of pi, right? So here we are given a function f which is given to be a continuous function such that we have this equation for all values of t greater than 0, and we have to find the value of the function f at this point, that is pi, right? So here we'll make use of the concept of Leibniz integral rule, which is related to differentiating an integral, right? So let us start. So let us first quickly see the definition of Leibniz integral rule. Suppose we have an integral from 0 to u of t, and here we have a function, say f of x and dx, right? So here we are given an integral where the lower limit is 0 and the upper limit is a function of t, and the integrand is a function of x. So here we are not taking the general Leibniz integral rule, and here we are taking a particular case of Leibniz integral rule where the lower limit is 0 and the upper limit is a function of t, right? And if we wish to differentiate this function with respect to t, right? So the derivative of this integral with respect to t is simply given by f of u of t. So first we'll replace this x by u of t, which is the upper limit, and then we'll differentiate u of t with respect to t. So here we have d by dt of u of t. So this is the Leibniz integral rule when the lower limit is 0 and the upper limit is a function of t, right? So here in the given problem, the lower limit is 0 and the upper limit is a function of t. So we can compare this integral with this one. So we have u of t is equal to t cube, and this function f of x is given by this one, right? So let us differentiate both sides with respect to t. So now differentiating both sides with respect to t, we have d by dt of this integral, that is 0 to t cube, and we have f of pi x, and here we have 2 pi x raised to 4 dx, and in the right hand side we have pi times the derivative of t raised to 4, right? And now applying this rule to this integral, we can simply replace x by t cube, right? So we have f of pi times t cube, and then we have minus 2 pi t cube raised to 4, because here we are replacing x by t cube and here the exponent is 4, right? And then we have the derivative of u of t, and u of t is t cube. So we have d by dt of t cube, and in the right hand side we have pi times 4 times t cube. So here we have applied the power rule for differentiation, that is n times t raised to n minus 1, right? Okay, so now we have f of pi t cube, and then we have here minus 2 pi t raised to 12. This is 3 times 4 is 12, and here we have 3t square, and here we have 4 pi, and this is t cube. So now let us rearrange the terms. So we have f of pi t cube, and then we have minus 2 pi t raised to 12, and taking 3t square in the denominator of 4 pi t cube, we have 4 pi t cube over 3t square. So now here we can easily cancel t square with this term, that is t cube, and we are left with 4 pi over 3 times t, right? And here it is important to note that t is greater than 0. So we can cancel out this t square with t cube. So now we can write f of pi t cube is equal to 4 pi over 3 t plus 2 pi times t raised to 12, right? So now we have arrived at this important relation which defines this function f of pi t cube as 4 pi t over 3 plus 2 pi t raised to 12. Now we need to find out the value of f of pi, right? So now if we replace this t by 1, right? So replacing this t by 1, here we can now write f of pi times 1 cube, so that this becomes pi. Pi times 1 cube is pi, and we can easily get the value of f of pi. So here we have 4 pi over 3 times 1, t is equal to 1, and then we have 2 pi, and here 1 raised to 12. So now we can write f of pi. Here we have 4 pi over 3, and this is simply 2 pi. 1 raised to 12 is 1, and here adding these two like terms, we have 4 pi plus 6 pi over 3, that is 10 pi over 3. So the value of f of pi is given by 10 pi over 3. So viewers, this is how by the application of Leibniz integral rule we can easily find out the value of f of pi, and when it is given that this function f is a continuous function which is defined by this equation for all values of t greater than 0.